Hi there, this is Mrs McTaggart. In this video we're going to be looking at the topic called indices, and we're going to be looking at two rows in one go here. We're going to be looking at multiplying and dividing indices. So before I start, let's explain what an index is. Indices are all about powers and rules, and if you learn the rules, you'll be okay with this topic. And you've actually been doing indices before without even realising it. You've probably just not had it used as that word before. So if you were given, for example, this example here of a squared, the power bit is called your index number, and the a is classed as your base. So you're doing base a to the power 2, which we know is a squared. Now, to prove the first rule of indices, I'm going to just take this very simple example of a squared and remind you that a squared can be written as a times a. And then a cubed can be written as a times a times a. So if I then asked you to do a squared times a cubed, well, that could be written as a times a for a squared multiplied by a times a for a cubed. Now there's 5 a's there all together, so times them by itself 5 times would be written as a to the power 5. Now there is another way to get to power 5 without having to constantly write it out like this, and the connection is, hopefully you'll see it, 2 plus 3 equals 5. So the rule for multiplying indices is that we add the powers. Similarly, if I asked you to divide these, if I asked you to do a, oops, a daisy, wrong pen. If I asked you to do a cubed divided by a squared, well, we could think of that as a times a times a over a times a. And we could do the good old scoring out. We could cancel out 2 from the bottom, 2 from the top, and that would just leave you with a. Now, although that doesn't have a power, it does have a wee secret power of 1 that we just don't write. And another way of getting that power using the 3 and the 2 is to do 3 subtract 2. So the rule for dividing indices is we subtract the powers. And remember, multiplication and division are just the opposites of each other. So it makes sense that the index rules are the opposite of each other. So here are the two rules written out in kind of like mathematical formula form. So rule 1, for multiplying indices, you add the powers, and I've just expressed that as m plus n up here. And for dividing, you're subtracting the powers, so I've written that as m minus n. M and n are just used in place of any particular numbers here. And I've just reminded you there are two ways to write a division. We can write it as a divide left to right, or we can write it as a fraction. So the best way to work through these is, let's go do some examples. So example 1, a cubed times a to the power 4. Well, realise that we add these powers. So we're really doing a to the power 3 plus 4, which is just a to the power 7. Now, there's no need to write the 3 plus 4 bit. This is just me reminding you of what's going on here. And on this one, we've got b to the power 8 times b to the negative 2. Well, that would just be b to the power 8 plus negative 2. And if you cast your mind back to doing basic integers, that's just the same as 8 take away 2. So although we said we're adding when there's negative numbers in, it does turn into a wee bit of a subtraction. So that is 8 plus negative 2, which is a power 6. So that becomes b to the power 6. So how to make it harder? Well, we start to put numbers in front. Now, you should already have been familiar with multiplying out brackets. Maybe not with its powers as high as cubed and power 4. But if you were asked to do 2c times 4c, you would have been multiplying the 2 times the 4 together first. Same here. So we're doing 2 times 4 is a power 8. 2 times 4 is 8. And then for our power, we've got 3 plus 4, which is just 7 again. So 8c to the power 7. And I'm going to start writing that I'm adding the 3 and the 4 together. Now in this one, again, we'd multiply the 7 times the 4, which gives us 28. Now I've put this one in because sometimes people forget the letter D, without a power, really has a power 1. So we're doing 1 plus 4, which gives you a power 5. And you should already be familiar with it. When you multiply something by D, it increases the power by 1. So it becomes 1 plus 4, power 5. Then I'm going to do some division 1. So I've already kind of done one a wee bit like this when I was trying to explain what the rule was. So this is a divide, and it's just all about spotting that a fraction is still a divide sum. So we're doing a to the power 6 minus 3, which is just a cubed. And honestly, if you forget indices and you forget the rule, the really simple way is to write this out with your 6a's all stuck together, your 3a's all stuck together, and score them out. And the minute you do that, it just reminds you, oh, it's a cubed, I'm subtracting the powers. So that is just a good little trick for that one if you want to double check. Same on this one, we're going to do the numbers first. So 18 divided by 3 is 6. We're going to subtract the 4 and the 2. So 4 take away 2 is just 2. So this one is 6n squared. Okay, nearly done. We're getting on to the biggies here. So on this one, we have 8p cubed divided by 6p to the negative 2. If I do the numbers first, 8 doesn't divide by 6 exactly, but it does simplify down. 8 and 6 are both even numbers, so I can half them both, which gives me 4/3. And then I can do the subtraction of the powers. Now, this actually says p to the power 3 minus 2. So it's actually becoming a little bit of an addition. So minus turns into a plus. So this is really 4/3 p to the power 5. Now there's a couple of ways that you can write this one. I've written it with the 4/3 out the front. You could also write it as 4p to the power 5 all over 3. But to be honest, this is a better way to do it for when you're coming to do this topic in higher. It's nicer to have the fraction out the front. And this one here, if you're ever presented with a fraction, do the top bit first, or sometimes the multiplication can appear in the bottom. Tidy that up first as well. So I'm going to do the top line. Now this would be worth 2 marks, so I'm going to show the 2 steps of working. So when I do the top line, 4 times 3 is 12. 5 plus 2 is 7, so I've got 12m to the 7 all over, and I'll leave the bottom line just now as 6m to the negative 3. 12 divided by 6 is exactly 2. And then I'm doing 7 minus 3. And do you know what? It's okay to just do that at the side just to clear up that and make it more visual that it's going to become an add. So 7 minus 3 becomes power 10. And there's your final answer for that one. Now that's a good example of an exam one. And we would expect to see both steps are working, particularly if you want to gain full marks. In case you make a wee mistake, if you try and go right to the answer at the end without this little interim line in the middle here, you could end up with nothing. So please show your steps, okay? And then my last two. So number 9 I've based on a previous exam question that I remember not being done particularly well. So literally take your y's first and then do your z's. So if we're looking at the y's, we're dividing. Remember, this has got a wee secret power of 1 on it. So the y's are going to be y to the power 3 take away 1 is 2, so y squared. And the z's are going to be to the power 4 minus 3. So that turns into a plus, so that would be z to the power 7. And my last one is brackets. Brackets quite often put pupils off, but just remember, do what you would normally do. You would multiply out. So a squared times a, and that's got a wee power of 1, would go up to a cubed. And then 4 times the a's would give you a 4 at the front, a, and then we've got 2 minus 3, so 2 plus 3 is the power of 5. And then, of course, you cannot add them together because a cubed and a to the power of 5 are completely different terms. So please do not be tempted to then say collectively that is something else. This is your final answer. So that's me taking you on a whistle-stop tour of indices, the first 2 rows of multiplication and division. Feel free to watch my next video where I'm going to be doing raising powers to the power and talking about the power 0. Thanks very much for watching. Bye.